going to. So this time would be hopefully much faster and make a lot more sense. So this time, let's say D. Setup. Create Delilah. Then create John. Okay, just a quick plan for myself. So we'll start again with the setup. That's like step 0 because that's usually the beginning of each exercise of this type.
Was that 60
What?
degrees?
Oh,
Or no?
this is going to be a dividing line that will give me a 90 degree, and then I'll figure out 60 from there.
What were you measuring out? 90? Or
Oh, all I was doing was bisecting this line.
like how far do you open it? Just all the way, or?
Like, sometimes I get lucky and sometimes I don't with this measurement.
You just need to exceed half of that line.
Okay.
Yeah, just slightly half over, exactly.
If you like go lower than the half, it doesn't intersect, so you won't have it.
Wait, Katarina?
Yeah,
What is this? What are these marks?
bisector.
Oh,
Remember
okay.
when we're bisecting a line? So we're using your compass to bisect this line to create the dividing line.
I don't remember bisecting anything. All I remember is telling us to make an eye level.
Oh, we're doing the setup now for the 60.
Oh, you're doing this?
Yeah.
Oh, okay.
Yeah. I'm just repeating the same process because the last one was a little haphazard the way I explained it. Now, step 1, create the Delilah. Step 2, create the perpendicular line under it. You use a compass once again and just align your transparent compass line right through. Now replicate the size of the Delilah so you have the true view sizes of the cube on both sides. You later use these points to match the perspective rulers we'll create by placing the MPs. So we'll move the VP lines here to this one, VP1 to here, and VP2 all the way to here. So we'll need this distance. Technical difficulties. I'm so thrilled that the portfolio is finally over. It's one less worry. I'm just glad that's done.
Oh, do you get to hear?
I'll get my results on Monday.
Oh, you're gonna pass
You were
anyway.
gonna pass.
Yeah, you're good.
So here's your MP1, since it carried this way, and here's VP2. See, from this station point, the VPs are at 90, but now we need to move them over here for the two lines, the two back convergences. So that's why we move them up here. MP2. So just think of the measuring points as rulers for convergence. And you need a true view to get the rulers working for you. Now let's converge the cube as we generally do to the VPs. So converging the Delilah to both sides. And now we'll do the cutting. So we'll decide just exactly how much does each bottom line converge using MPs and these endpoints of the sides. We'll take this right point to MP2. And this is where it crosses. And we'll take this left one to MP1. And this is where it crosses. Now, here's the actual point, and here's the actual point. Now we bring this point up into a line. So we get, now we need to know where this point, since it's a cube, we need to know where this point replicates here. So, here, and I'm eyeballing it. If you want, you can always use dividers for to figure out this line and place it over, especially if you're trying to make a very large cube. You don't want to disproportion it somehow. Now you have these 2 points, and these 2 points you bring over to VP1 and VP2. So now you know how they converge and where they're located. So the MPs tell location, and VPs show convergence. And both have the same convergence rate. You just need extra measuring points to know where a line could go. So now we're almost done with our cube, and we can bring this point over to VP2. We can bring this point over to VP1. And we have our cube. Okay, so that's the mechanical way of making a cube. And we can do the same inside. So we can bring these 2 lines over 2, so we have the inside of a cube, and we can see what that looks like. And that's especially helpful later on when I introduce shadows and light. You'll see why that's really important, especially if you like making a cylinder and you need to know where the shadow is. So it's good to draw through whatever you're doing, whether it's in figure drawing or this. It's really important to draw through because then you'll get an understanding of the structure. So now since I have this point already, so this is the inside of the cube. So this is a perfect cube in perspective.
What did these lines do again for us?
Oh, these lines show they lead you from the endpoints over here, these 2, over to the MPs, just so you can see what the convergence is, like what the location is of the points on these 2 bottom parts.
Which one? Which line?
Oh,
Which location?
This one. It just tells you how much this line converges. So, how much converge? And VPs were 2. So, the MPs, you only need them a couple times, 2 times actually, for a cube. And they're very specific to a cube. You just need them basically to show you how much of convergence there is for this line. This is how much this is what it looks like in real view, like if you just have a cube facing you. But if it's if it's actually tilted, if the cube is tilted like this, if it's rotated this way, you're not going to see the true view, you're going to see some portion of it. And this line leads to an MP, a measuring point, that shows you just how much you will see.
Okay. I mean, I understand it, but I'm just like trying to.
Oh, no one
Yeah.
really understands.
I don't get the part that you measure the measuring point. Why is that specific
It's,
distance?
oh, you mean this when it goes like that?
Yeah.
Because it brings, if you're standing here, you're seeing equally this much and this much at a 90 degree, and this is your location here as a viewer. So if something is converging visually for you, you're bringing over this distance right here on the eye level just to see by how much it's going to the lines are going to converge. So like if you're standing here, you have this line and this line going this way for you. But what you're trying to figure out with the measuring points is just how much it is actually converging. So what you do is you move the same line you have here over to the eye level, and this line over here, and this is how you would be able to cut this perpendicular line to the MPs to get the lengths after you converge these two sides.
Can I explain it a different